Hi, I'm Reagan Cole, and this is my video lab report for Experiment 6, Chemical Equilibrium. So my three equations are written on the board. I know it's backwards. I don't know why Screencastify is doing that, and I don't really know how to flip it. So I will read off the chemical equations, but they're here on the board. I'm doing part A, part D, and part F. So part A was the acidic acid in the acetate equilibrium solution. So that equation for this particular part of the lab report was CH3COOH aqueous yields CH3COO minus aqueous plus H plus aqueous. So that's up there. Explain the significance of the first pH measurement. So the significance of the first pH measured, that was around 4.5. This was to provide a base to compare our findings to after the reaction had occurred. So if we knew the original pH was 4.5, we could compare it to our findings after the reaction happened to see if it shifted left or right towards the products or reactions. And this could help us determine the stress, the shift, and why this happened. So that's why it is significant to know that first pH. Part B was explain what happened when the sodium acetate was added. So in this part of the reaction, sodium acetate was our stress, and by increasing the pH from the sodium acetate, there's an increase of the hydroxide ions, and from Le Chatelier's principle, this causes the equilibrium to counteract that, meaning it shifts towards the reactants. So that's how we knew there was a shift to the reactions, because after this happened, after this sodium acetate solution was added, it turned to a pH of 6. That was all I had for part A. Part D was the cobalt chloride slash cobalt chloride equilibrium. Excuse me. So the equation for this was COH2O6 plus 2 aqueous plus 4Cl minus aqueous yielded COCl4 2 minus aqueous plus 6 H2O liquid. So that's up here. Okay, the first part was what color is COH26 2 plus ion? And that was right here. That was pink. And the COCl4 2 minus right here was blue. That ion was blue. So part B was explain the color change that occurs when hydrochloric acid was added. So in this particular part of this reaction, hydrochloric acid was the stress, and when adding the hydrochloric acid to the reaction, it turned originally from the pink solution to blue. So originally it was a pink liquid with the COH2O6 2 plus ion. It was pink, and then once we added the hydrochloric acid, it turned blue. So this was a shift to the right or to the products. Our observations supported this because our observation supported this with the equation because the ion COCl4 2 minus is blue. So Le Chatelier's says that adding that would shift it to the right, and we saw that because it shifted towards the blue side. Next part, C, was explain the color change when heat was added or removed. So the first part, when heat was added, heat was the stress. When heat was added, the solution turned a darker shade of blue, so it shifted more towards this side, the right. And this meant that there was a higher presence of the COCl4 2 minus ion because it was a deeper, darker shade of blue. Le Chatelier says that this is a shift to the right again, or the product side. And Le Chatelier also said that when temperature is increased, there's a shift to the right, and therefore the reaction is endothermic. So our observations, once more, did support this because it turned that darker shade of blue, which is on the reaction side. And then the opposite, when heat was removed, it turned a lighter shade of violet, almost like a lighter pink, which was on the left-hand side, or the reactants. So that meant there was more COH2O6 plus 2. And we already know this is an endothermic reaction, so Le Chatelier says that when heat is removed from an endothermic reaction, it's a shift back to the left, And this is also supported by our observations, like I said previously, because it went from that original blue color back to the light pink. Okay, and then that was a shift to the left. So explain whether this is an endothermic or exothermic reaction. So the reaction was an endothermic reaction because heat is a reactant. This is an endothermic reaction because an increased amount of heat shifts the reaction to the left, which we observed, with the blue color, and the removal of it shifted it right, which we observed when the color changed from the blue to the light pink. So heat was a reactant, so it shifted it depending on whether it was added or removed. So that's how we know it was endothermic. So that was all I had for part D. So part F was the bicarbonate/carbon dioxide equilibrium. And the equation here, hopefully I don't get in the way of it, was HCO3 minus aqueous CO2 gas plus OH minus aqueous. So part A was which chemical species was removed by aspiration. So the stress that was being applied to this part of the equation was when the solution was attached to a vacuum aspirator, which removed the gas in the solution. And this gas was CO2. So the CO2 was the chemical species that was removed. And because the gas was removed, we observed the original solution, which was a greenish yellow color, start to bubble. And it started to bubble because the gas was being removed. And then we observed a color change from the greenish yellow to a light blue. Le Chatelier states that this is a shift to the right because the solution turned blue, and HCl is blue. So our observations supported this because we saw a lighter shade of blue as the final product when CO2 was removed. So our observations supported that it was a shift to the right because it was over here. So that's all I had for the video chem lab report.